So today is August 8th. So let's go to that calendar there. August 8th is a Thursday, and we will be learning these three lessons. Well, we'll be learning 1 hour's worth of something that's covering these three lessons. So transformations, I spent a lot of time on transformations yesterday, so I'm not going to do it again today because, I already did that. So we will either be, spending most of the time on this one or this one. Both. Actually, they're pretty related. So yeah. So I can probably do both of them. Yeah. All right, easy stuff. Today's a pretty easy lesson. Today is a lot of review from grade 10. And let's get started. Okay. Actually, wait, where did it go again? Zeros, roots of quadratics. All right. Yeah, this is it. Let me just double check. And this is linear quadratic system, I'm pretty sure. Yeah, linear quadratic system. So yeah, so our two lessons, like my notes, are going to be in Unit 1, Lesson 6 and 7. Those are the notes that I use. But of course, if you're following, the proper, format, Unit 2, Lesson 5, 6, 7. So the proper format is this. If you ever get lost, just use calendar and go through these sections. All the proper headings and notes are always there. But if you want to use my notes, then they're not aligned with the way they're aligned because I teach my course in a different order, usually. So that's the only reason why it's different. But the material is the same. So eventually we'll cover everything. But yeah, just so you know, Unit 1, Lesson 6 and 7 are my notes. So let's get started with what are we learning today from grade 10? Basically, quadratic formula. That's basically it. I'm going to start with a simple quadratic equation like that. All right, question for the class, and I want an answer. How many x-intercepts does this parabola have? How many x-intercepts does this parabola have? Just type it in the chat, anyone. All right, we got 2 people saying 2. Another one 2. And guess what? Everyone who said 2 is correct. It's not a trick question. These are the 2 x-intercepts. Now, question is it possible to have more than 2 x-intercepts for a parabola? What do you guys think? We'll do a quick poll. Thumbs up, thumbs down. Thumbs up meaning yes, you think it's possible for a parabola to have more than 2 x-intercepts. Thumbs down meaning no, you think 2 is the highest. You cannot have more than 2. All right. I don't know if the poll's working or not. Did I do it? Is it there? I have no idea. All right. Perfect. So less than half have responded. So I don't know what's going on, but that's okay. It's not that hard. So most of you got it, or I think all of you got it, the ones who responded. So 2 is the highest maximum amount of x-intercepts you can have. You cannot have 3, you cannot have 4, you cannot have 5, blah, 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 blah. Question now is, is it possible to have less than 2 x-intercepts? Can a parabola have less than 2? What do you think? I'm going to put a poll. Same thing. So, excuse me. Thumbs up if you think the parabola can have less than 2. Thumbs down if you think, no, it can only have 2. So, thumbs up if you think it can have less than 2 x-intercepts. Thumbs down if you think it can only have 2. I'm waiting for people. So once again, thumbs up if you think it can have less than 2 x-intercepts. Thumbs down if you think it's only possible for it to have 2 x-intercepts. Okay, only like 13 people responding, so I'm not going to wait any longer. This is not a rocket science. You just click a button. So if you can't do that in time, I don't know what to do. So most of you got this right. And some of you are going to be surprised to hear that, you know what? A parabola can have less than 2. And this is an example. It's okay, Lynn. It's not a big deal. Voting is not for marks. It's more for me to see who's, participating, classroom involvement, engagement, all that fun stuff. Okay. So this is an example of a parabola having 1 x-intercept. So for those of you who thought it's impossible for it to have less than 2, think again. You can definitely have less than 2. And finally, I don't want to take too much time, but here's an example of a parabola having 0 x-intercepts. So that's even a possibility. So this is an example of 0. Why? Because it doesn't even touch the x-axis. That means it has no x-intercept. So that's an example of no x-intercepts. And here are the 3 examples from my notes. So we have 2 x-intercepts, 1 x-intercept, no x-intercepts. And we can use math or algebraic math to figure out without graphing. If the equation of a parabola is given in standard form, we don't have to graph it because it's hard to graph a parabola when it's given in standard form, as opposed to, let's say, vertex form. Because vertex form, we know the vertex, we can just draw, graph the vertex and then kind of graph the parabola that way. But if it's in standard form, it's a bit harder to just do it right away. But we have other tricks that we can use when the equation is given in standard form. We can use the quadratic formula. And specifically, we can use the discriminant. The discriminant is the part of the quadratic formula that's underneath the square root sign. For those of you who don't remember the quadratic formula, I'm sure actually I have it here somewhere. Maybe I do, maybe I don't. Nope, I don't. Lies. It's probably in here. There it is. Alright, so here we have the quadratic formula. In case anyone forgot, you might want to memorize this. It's all from grade 10. This is not new. Everything right now is from grade 10. Okay. The discriminant is this part here underneath the square root sign, b squared minus 4ac. And if we're looking for, listen to me carefully, if we're looking for how many x-intercepts the parabola has, we don't have to do the full quadratic formula. We can just take a look at the discriminant and see if the discriminant is bigger than 0, or if the discriminant is, say, equal to 0, or if the discriminant is less than 0. And there are 3 scenarios here, and each one of these scenarios corresponds to how many x-intercepts a parabola can have. So if the discriminant is bigger than 0, that is an example of 2 x-intercepts. If the discriminant is